All right, so we did condensing and expanding. Those properties and that skill is going to help you to solve logarithmic equation. Well, to solve equations using logs. So basically, there's a couple of things outlined in the top here. A lot of them are, well, some of them are not going to make much sense until after we kind of go through the notes. Then you'll know what we're talking about. But a logarithmic equation just has a log in it. Okay? Just notice that the base of a log has to be positive and real. Okay? So, and not equal to 1. That's true too. One-to-one property is the same type of deal. For every x, there's one y. But if you look at this property, it's going to help us solve equations later. It's basically saying if you have an equation that looks like this with the same base, log base b of something equals log base b of something else. Well, if they're both log base b, then x must equal y. Whatever this something is has to be the same as this something if they're equal to each other. Okay, so we'll see that, like I said, this will make more sense when we solve some problems. Exponential equations we talked about before, right? An exponent is the variable, that's exponential. And then one-to-one property is what, basically, if you have b to the x equals b to the y, well then again, x must equal y. If you have 2 to the 5th and 2 to the x, well, x must be 5 because 2 to the 5th can only be equal to 2 to the 5th, right? So those are some important properties for solving. Okay, there are a bunch of methods here. Each method, what we're doing is we are solving for x, okay? We're trying to get x by itself. In order to do that, the situation might be different for each problem, and you can see that's why there's these different methods. Method 1 is used when there's a log in every term, and so that is a specific type of equation. Method 2 is going to be a different instance. Method 3 is going to be a different. So the trick is then, when we put them all together, getting to a problem and knowing which method you're using. But in all cases, your goal is to get x, a value for x. Okay? All right, so this is just an application of that one-to-one property of logs. If we have log base 3 of this, and it equals log base 3 of 52, well then, x squared plus 3 must equal 52. Does that make sense? So then you know how to solve this. Subtract 3 from both sides. X squared equals 49. And what's x? Thank you. Plus or minus 7. Right? Square. If you have x squared equals 49, you're going to have plus or minus 7. 2 answers. Okay, so that was nice because we had, on each side of the equal sign, we had a log, one log written once with the same base on both sides. And so we were able to just kind of cancel out those logs and solve our equation. So we get to number 2, and we don't quite have the same situation because there's a plus sign there. Well, this is where our condensing and expanding is going to help us, right? The left side of the equation I'm going to leave as log base 4 of x. But the right-hand side is an addition, which means we can write it with 1 log base 4 of what? Yeah, 3 times x minus 2. Because an addition condenses to just multiplying those terms together. Now we're back to having this situation. We have a log base 4 on both sides. We can kind of just cancel those out. And x equals 3 times x minus 2. So then we keep going to solve this. And we get 2x equals 6 and x equals 3. Positive, right? Yep. That make sense? So here this becomes x squared plus 11 equals 92. X turns out to be plus or minus 9. Here this turned out to be 6x equals 9 times x minus 4. And x turned out to be 12. Anybody have questions on those? Okay, so try the last two. All right, so when we condense this one and simplify, we get 3x equals x plus 5 over 2. Cross multiply, you get 6x equals x plus 5. And x is, turn to the page again, x is 1. Here we end up with ln of 10 over 5 equals ln of 2x minus 9, which ends up just 2 equals 2x minus 9, and x equals 11 over 2. We've talked about things that are not in the domain, right? Well, for a log, the log of something is always positive, okay? Because remember, it's the inverse of an exponent, right? So there's no way to get a negative by doing the log. So you cannot take the log of a negative number or of 0, okay? So that's important. You can't have log base b of negative 5. That's saying b to what power equals negative 5. There's no such thing. Right? There's no way to get something to be a negative number just by raising it to a power. Because if we raise something to a negative power, it ends up a fraction, right? It doesn't make the thing negative. So you cannot have log base b of 0 either. Something to what power equals 0. Because if we raise something to the 0 power, we get 1. So there's no way to raise something to a power and get 0. No way to raise something to a power and get a negative. So you cannot have x be anything but a positive number. Okay? So when we solve things, we have to make sure that our solutions are actually, solutions that work in our problem. So for this one, we're going to do the same process here. We have ln of 7x plus 3 over x plus 1 equals ln of 2x. And then our ln's kind of cancel. Think of this as cross multiplying. We get 7x plus 3 equals 2x times x plus 1. Well, 7x plus 3 equals 2x squared plus 2x. If we distribute, well, we've got squareds and x's, so how are we going to have to actually solve for x here? Factor, exactly. So we need to subtract 7x from this side and 3 from that side. And we end up with 0 equals 2x squared minus 5x minus 3. Which then we need to factor. So you've got 2x and x. What multiplies to be 3? Well, we only have 3 and 1 as our possibilities. We just have to figure out which one goes where. If I put the 3 here, it's going to multiply by the 2x and get 6, and then that'll work. So we need minus 3 plus 1. That's our factored form. So what does that mean? That means x equals either 3 or negative 1/2. Well, let's go back to our original. Does negative 1/2 work if I plug it in for x in my original? No, pick any one of these, right? ln of 2x. If x is negative 1/2, that becomes ln of negative 1. And we just said we cannot take the log of a negative number. So we have to cross out negative 1/2 because it's an extraneous solution. 3 works. Now, just be careful because it's not always the negative one that's going to cross out. I mean, what if this said, you know, ln of x minus 5? Well, then could x be 3? No, because 3 minus 5 is negative 2. So it's not necessarily just the negative x's that cross out. It's whatever plugs in to make a negative. In this case, the negative one plugged in to make a negative. But you really need to check, you know, both of them. Don't just automatically assume that a negative is going to cancel out. Okay, I'm going to move on to method 2, just since we've got shortened classes here today and we need to get through a little bit more than what we have. Method 2 is used when there are terms with logs and without logs. So far we've had everything had a log. Here, not necessarily. And sometimes there's more than one way to solve these. But here's the steps. Bring all the logs to one side and then condense them. And then rewrite it in exponential form. So you have done converting logs into exponential form before, right? If I have log base 2 of 8 equals x, and I said write this in exponential form, you would say 2 to the x equals 8, right? You've done that before. You know how to turn things from logs into exponents and back and forth. So that's what this means right here. Rewrite it in exponential form. If you get all the logs to one side and condense them, you just have one log statement. And then you have a whole number on the other side, so you should be able to then make it something you can solve. So let's take this first one, for example. ln of x equals 6. Well, if I were going to write this in exponential form, what would it be? Yep, e to the 6th equals x. Right? Because an ln is a base e, so there's like a little e there. E to the 6th equals x. So that's really just rewriting it now, we can be done. Because at this point, we solved for x, and in your calculator, you can just push e to the 6th, and you'll get an answer, right? So this is done. But let's look at number 2. So the first step is to get all the logs on one side and isolated. So we're going to subtract 6 from both sides. That leaves me with log 5x equals 2. So how can we write that in exponential form? What is the base of that log? 10. So we can write it as 10 to the second equals 5x. Right? If that step is confusing you, you got to take care of that, because that's, since before the midterm, turning things from logs to exponents. That needs to be something you're comfortable with. All right? If you need help with that, let me know. Okay, well then 10 squared is just 100. 100 equals 5x. What's x? All right. Try number 3 and number 4. Tricky, sorry. Forgot that this one has a little trick to it. This is that one-to-one property of exponents. So let's do this one together. So when you rewrite this in exponential form, it becomes 8 to the 12th equals x to the 6th. Uh-oh, now what? Right? So what you want to do is undo the x to the 6th, right? I mean, if you're solving for x, you need to undo whatever's being done to x. You've been doing that since Algebra 1, right? If they add to x, you subtract. If they multiply, we divide. If they square it, we square root it, right? So you know how to undo something to a power. If it was to the 2nd power, you took the square root. Well, if it's to the 6th power, what do we do? Take the 6th root. Okay, but another way of taking the 6th root is raising something to the what power? 1/6. So think about taking x to the 6th to the 1/6 power. Right? And that 6 is over 1, so when you do a power of a power, you multiply, so this just turns out to be x. Right? X to the 6th to the 1/6 is just x. But if you do something to the 1/6 on that side, you have to do it to the 1/6 on this side. Again, think of the 12 over 1. Now you've got 8 to the 12/6. See how 12 over 1 times 1 over 6 gives you 12/6? What's 12/6? 2. So this is just 8 squared. So x is 64. So you have to remember that undoing something to a power is just taking it to the, really the reciprocal of that power. If this is not on here, but if you had x to the 2/3 equals 5 or something like that, what would you have to raise this to get it to cancel out? 3 over 2. Because you just want this to cancel. Well, then you would raise 5 to the 3 over 2 power, right? So you have to get used to sort of, knowing how to get rid of those exponents. Okay, so number 4, you should divide by -3 on both sides first. You get ln of x equals 8. So that's just e to the 8th equals x. Okay, I wanted to get to one more method before the end of the period. So, did you guys try numbers 5 and 6 here or not yet? All right, so you should divide both sides by -3 first. You get log of 5x equals -2. Rewrite it as 10 to the -2 equals 5x. 10 to the -2 is 1 over 10 squared, which is 100, equals 5x. You're going to divide both sides by 5, and you get x equals 1 over 500. Okay. This one turned out to be plus or minus the square root of 82, which could be written a number of different ways, but I would like to move on. So we're going to go to method 3. Luckily, is not. This is an important one because it gets used a lot. This is when you have an exponential expression on both sides. And what you want to do, this is that exponential one-to-one property. What you want to do, basically, is express all of the things with the same base. So you're rewriting things so that they have the same base. So here we have a base of 6. Well, how could I write 36 with a base of 6? 6 squared. So 36 to the x plus 1 is like 6 squared to the x plus 1. What you have to remember is that exponent x plus 1 is in parentheses. You have to think of it as a whole unit. So now, when you have a power of a power, we multiply those out. This ends up 6 to the 2x plus 2 equals 6 to the x plus 6. Well, here's that one-to-one property. If it's 6 to the something equals 6 to the something, those two somethings must equal each other. So you can kind of, just like we did with logs, you can kind of just cancel out those 6's. And think of this as 2x plus 2 equals x plus 6. And then solve. X equals, what, 4? Now, sometimes it's a little trickier than others. This is, number 2 is 1/2 to the c equals 64 to the 1/2. Give me 30 seconds. Give me 30 seconds. What could both of those have the same base as? 2, right? So think of this as 2 to the -1 and 2 to the 6th, right? This is to the c, this is to the 1/2. So you basically have -c equals 3, and c equals -3. All right, so let me figure out your homework here. All right, so homework is 3 and 4, and the last page, 1 through 7. 1 through 7.